So why in the world do we need to know about concentration? If you look at the syllabus again, you need to identify the names of these apparatus. This is called volumetric pipette. A lot of students can't spell it properly. These are technical spelling. P-I-P-E-T-T-E, pipette. Pipettes are basically the plural, and you need to know volumetric flux, balances. Balances here refer to mass balance because you are using it to measure mass. So pipette, volumetric flux, and also balances. You need to prepare solutions of non-concentrations because we know it's something to do with masses. So we need to measure a mass using a mass balance. There's an apparatus you need to know in physics as well. But then we also need the volume of solutions. And to prepare solutions, we need something called volumetric flux. But to know the exact volume of solution that we need something called volumetric pipette. So to measure out volume, we need this apparatus. This is called a mass balance. Sometimes people call it electronic balance because it measures the mass of something you put on top of it. Is an electronic balance, is a mass balance. So what does it measure? It measures masses. Mass of what? Well, you're trying to prepare a solution, so you need the mass. Well, you need the mass of solute, which is in gram, and then you dissolve it in the volume of solution. So that is how you get concentration just now, right? And then this is measuring volume. Actually, it's not to measure, it's to make up something called stock solutions, and that is what lab technicians do for us when the pure science students have to do practical. Okay, so this one record or measure mass. This one is to measure volume. One of the biggest issue with using a pipette, this is called a pipette, P-I-P-E-T-T-E. Make sure you know how to spell it. This is called a volumetric flux. So a pipette cannot stand on its own. You need to support it on a retort stand. Volumetric flux has a flat base. It can stand on its own, and it comes in various sizes. Sometimes they have 100 cm cube, 250 cm cube, 500 cm cube, 1 liter, and so on and so forth. Remember just now, 1 liter was 1000 cm cube. And then to convert cm cube to liter or to convert cm cube to dm cube, because we don't actually use 1 liter in science, in chemistry. So to convert cm cube to dm cube, we simply divide whatever value by 1000. So pipette only measures a fixed volume, but they are very accurate. So these are just various sizes of pipettes. They do not measure volumes in between. So 10 there should be 10.0 actually. Volumetric flux is used to make a stock solution. Mass balance is used to measure the mass of the solid to be dissolved. The solid to be dissolved in the solution is what you call solute. Okay, so that's pretty much it really for this topic, but I'll just like to show you something that the lab technicians, our lab technician in school, would actually be preparing for each candidate's O-level exam candidates. The chemistry students do practical chemistry, so they have things like potassium hydroxide, potassium ions, hydroxide ion is OH minus, so potassium hydroxide is actually KOH. Ammonium chloride, ammonium is NH4 plus, chloride Cl minus, plus 1 minus 1. Well, we think about the valency, we're just looking at the charges 1 and 1. So obviously when they crisscross, just like the potassium hydroxide, you just have 1 of each. That formula is NH4Cl, that formula is KOH. Now, what is their instruction? Their instruction is to dissolve 5.6 gram of KOH in each dm cube. Each mean 1. dm cube, well, dm cube mean 1 dm cube. So you need a 1 dm cube volumetric flux. Questions in combined science will ask you, what do you need? Well, you need a 1 dm cube volumetric flux. If I have a 1 dm cube volumetric flux, I just need to put in 5.6 gram of KOH. All right, so what I have is I have a mass balance. I can't do a mass balance that well, but they call it a balance. I call it mass balance. You record 5.6 gram of KOH, and then what happens is you take a beaker and then you have some distilled water So obviously we are not going to put in all 1 dm cube of water in there. Instead, what we're going to do is, I can't draw that well. Actually. So there is your KOH solid. Pour it in there. You want to stir to dissolve, and then when you try to dissolve it, most of it, after that, then you transfer it into the volumetric flux. But then this is your volumetric flux. Remember just now we said we use a 1 dm cube volumetric flux. You could use a 500 cm cube one, but then your mass will have to change in order to get to the same concentration. Anyway, so assuming you use a 1 dm cube volumetric flux, then 5.6 gram works according to the instruction. What happened is you need to top up. You need to add more water because you haven't reached the 1 dm cube mark. So you need to add more distilled water. When you add more distilled water until you have 1 dm cube solution, then you stop it and then you shake it just like how you would make a Milo drink, and then you will get a concentration of 5.6 gram per dm cube of KOH, which is solution P. And then this technician will go and prepare solution R, which is by dissolving 53.5 gram of NH4Cl in each dm cube solution, and so on and so forth. So these are just procedures to make up that. Let me just highlight this. This is not very important. This is not very important for combined science, so I wouldn't be too worried if you think it's too wordy and too much for you. Don't worry about it too much. Just importantly, be able to identify like mass balance in order to read out masses, in order to use to make up a stock solution from the solid. You need this conversion factor. So we use dm cube, we use cm cube a lot. We use distilled water in the lab. We use volumetric flux as stated in your syllabus. And then what else? We know about concentrations. We know about the meaning of these. This is 5.6 gram of solute, and then this is 1 dm cube of solution. So it's all based on the instructions as given from Cambridge to the lab technicians, so that our pure chemistry students who are doing practical get a solution of a known concentration as required by Cambridge for their O-level examinations. So imagine if you, as a lab technician, if you can't do this kind of simple calculations, you will mess up someone's future. All right. However, this is very important for calculation. All right. So this is the last bit I'll talk about. Just now we say we have 5.6 gram per dm cube, but if you don't have, but you still need the concentration, still need this concentration. What can you do if you have a 500 cm cube volumetric flux, or in this case you have a 250 cm cube volumetric flux? Well, you want the mass of solute, but then we only have 250 cm cube. We know that 1000 cm cube is equal to 1 dm cube. So how do you get cm cube to dm cube? You divide by 1000. This is cm cube, so I want to get it to dm cube. I will need to divide by 1000. So divide by 1000, that will become dm cube. This is in gram. What concentration do I want? I still want 5.6 gram per dm cube. So gram per dm cube means gram per 1 dm cube. Okay, so I'm just doing mathematics really. Just now the syllabus said candidates should be able to calculate. This is the kind of thing they want you to be able to calculate. The mass of solute is going to be that multiplied by that. Because I just bring the denominator to the very top, I multiply by this on both sides. Remember, this is on the other side because this is the concentration that you want to prepare, 5.6 gram per dm cube according to the instruction just now. Anyway, calculations just like these are mathematics stuff, so you know they can change from time to time. So there's 1.40 gram of the solute, and this is in 250 cm cube of distilled water. So, you know, if you don't have 1 liter or 1000 cm cube volumetric flux is this thing here that you need to prepare the solutions. This is 500 cm cube. So you could also practice using 500 cm cube. Of course, then you'll get 500 over 1000. Then your mass will be different. But if you have 1 dm cube volumetric flux, then you just prepare straight away 5.6 gram. Okay, so that's it really. So don't try and complicate the situations. Be able to identify apparatus. These apparatus are required: mass balance, volumetric flux, and volumetric pipette. Pipette is spelled with P-I-P-E-T-T-E, as stated in the syllabus. And of course, we need those to prepare solution. Solution is not a pure substance. It consists of the solute dissolved in solution, dissolved in the water. So the mass of solute in gram dissolved in 1 dm cube of solution, 1 dm cube of water, give you the unit of gram per dm cube as the concentration, which you need to be able to calculate. That's it for this lecture tutorial, the last bit on relative masses subtopic, and I'll see you in the next lecture tutorial next time. Thank you for watching. Don't forget to click the button on the bottom right to subscribe to the channel, and follow me at ptet.chemistry. That is at ptet.chemistry on Facebook, Instagram, Twitter, and Telegram. Okay? Hello again everyone, welcome back to ptet.chemistry channel. So this is supposed to be the last of these a series of lecture tutorials on this topic on relative masses. So prior to the end of your exams, I had to stop at the calculations bit, but now that we have finished those exams, then we can just continue on the last remaining bits in the syllabus. So here the new 2023 syllabus require candidates. This is for the combined science. Combined science is a foundation science lower tier. 5129 is also suitable for any for any of that foundation chemistry, foundation science in any other curriculum. So candidates are expected to calculate concentrations. So you need to do a bit of calculation. Is the mass of solute. Solute is the substance that is dissolved in a solvent. So you know, solute as defined in that topic on separation technique. So it's defined as the substance that dissolve in the solvent. So solvent is the stuff that you use to dissolve solute. So you know, the use of these terminologies are very important, and you dissolve the solute in a given volume of solution such that you get the units. This is gram per dm cube. So what does gram per dm cube means? It means, you know, you have the mass of something in gram. So mass of solute in gram, and then you have a solution. So you have a solution which is typically just water. So most of the time you'll be dealing with distilled water. So in the lab we don't use tap water because tap water is not pure. It contains other impurities. Distilled water is a pure water containing nothing else. So solution, and it's got to be volume of solution in dm cube. So your unit is going to be gram over dm cube. Then what is this dm cube thing here? Okay, so 1 dm cube is basically 1000 cm cube, and you know that 1 cm cube, we know in physics also, 1 cm cube is equal to 1 milliliter. So 1 dm cube is equal to 1000 milliliter, and we also know that 1000 milliliter is 1 liter. So you know, 1 dm cube basically means 1 liter. However, in chemistry, we specifically are told in the syllabus we need to use gram per dm cube. Just so you know, 1 liter is quite a big amount. It's about double the size of a typical 500 ml carbonated drink, bottled water drink. Okay. So definition of mass concentration is basically the concentration in gram per dm cube. I already mentioned that. Mass of solute dissolved in 1 dm cube volume of solution. Okay, so what does concentration actually mean? So when we have 2.5 gram, so this is mass. So what is our solute? Our solute here is copper 2 sulfate. If you remember formula, which you are supposed to, the copper 2 in the bracket refers to copper 2 plus ions. Sulfate is SO4 2 minus, so that you know you get the valency, which is 2 and 2. So when you do the crisscross, you're going to get 2 and 2. However, you can further simplify it since they are in the simplest ratio. So you simplify it, you get 1:1. So that means the formula of copper to sulfate is CuSO4. So if you have 2.5 gram of CuSO4 in 1 dm cube, so what happened is you want the unit to be gram per dm cube, so divide the mass of the solute by the volume of the solution. That's the meaning of concentration. Defined concentration is the mass of the solute in 1 dm cube of the solution. How about solution B? When you dissolve 25 gram of this thing in 1 dm cube, well, now you have 25 gram of CuSO4 in 1 dm cube of that distilled water there. So 25 divided by 1, 25 gram divided by 1 dm cube, you're going to get 25 gram per 1 dm cube. So this is the mass of the solute in 1 dm cube of solution. Now the next thing is a bit tricky because based on the definition, we need concentration to be in 1 dm cube. Is the mass of solute dissolved in 1 dm cube? This is dissolved in 0.5 dm cube. So how do you get concentration? Well, mass concentration is the mass of the solute, so 125 gram, but it's not divided by 1, it's divided by 0.5 dm cube. So you got to press your calculator. So 125 divided by 0.5, I get 250 gram in 1 dm cube. So in half dm cube, meaning half of 1 dm cube, there's 125 gram. So in 1 dm cube, there's 250 gram. As you can see, this is more concentrated than this because it has a lot of that solid dissolved in that amount of solvent or solution. Compared to this is 10 times more concentrated. This is also 10 times more concentrated than this. This have been represented by the color of the solution. So copper to sulfate later on, you will learn that copper 2 plus in solution is actually blue in color, blue solution. I'll show you when we go back to the lab eventually after all this COVID closure of schools. So you can see the color getting darker and darker because you dissolve more and more of that copper to sulfate. There is a lot more of that copper to sulfate in the same volume of solution. That's why the color is darker. Okay, so aqueous solution. Aqueous, basically we represent it as AQ. Aqueous means the solute is dissolved in water. Therefore, we are talking about a mixture and not a pure substance. All right. So just to give you further more examples, when you have 10 gram of NaCl, that is called sodium chloride. It is a classic giant ionic lattice structure, ionic compound consisting of metal cation and non-metal anion. So an ionic compound, you dissolve that in distilled water. So the concentration is going to be the mass of the solute, gram, divided by the volume. This is not 1 dm cube, but you want the definition of that concentration to be the mass of solute in 1 dm cube, as stated in the syllabus. Candidates should be able to do calculation, gram per dm cube. So convert this 10 gram, convert cm cube to dm cube. So this is cm cube, which is not correct. So we know that 1 dm cube just now, what did I say? 1 dm cube is 1000 cm cube. So you must know the conversion factor. This is simple mathematics. If that is true, so therefore, if you have 1 cm cube, that must be 1 over 1000 dm cube because cm cube is smaller than dm cube. When you convert cm cube to dm cube, you divide both sides by 1000. So what happened then is I can show you better in terms of mathematics. If you divide by 1000 here, you also divide by 1000 there because that is just mathematics. So 1 over 1000 dm cube equal to 1 cm cube. That's what it's saying there. So to convert 10 cm cube into dm cube, therefore 10 cm cube has to be divided by 1000 because I'm going from cm cube to dm cube. Okay, because the concentration has to be in gram, mass of solute dissolved in 1 dm cube volume of solution. So this is not entirely correct. What we have now is dm cube. So put it into your calculator. 10 divided by bracket. Okay, divided by bracket. 10 over 1000. And then you will get 1000 gram of NaCl divided by 1 dm cube. So what does it mean? It means that you have 1000 gram of sodium chloride dissolved in 1 dm cube of distilled water. So our solution is almost always water in your simple chemistry. So concentration in gram per dm cube.